Alright, in this video we're going to be solving different types of logarithmic function examples. So these are actually questions that I specially selected because of their nature. So the first question we're going to be solving now is x to the power of 1 plus log x is equal to 10x. This is the question. This is number one that we're going to be solving, and it looks kind of complex, but it's very simple. So what you need to do is, in logarithm you are permitted to, or in any mathematical equation you are permitted to introduce a log function to both sides when you are trying to drop a power. So that's exactly what we're going to do here. I'm going to introduce a logarithm function to both sides here. And for logarithm, we know that logarithm b a to the power of n is equals to n logarithm a to the power of b. That means the power can drop. Okay, so that would be that I will write 1 plus log x dropping to the other side just the way this n dropped, then log x, okay, is equal to log 10x. That's very, very simple and fair. So we can open the bracket here. We have log x plus log x squared. Alright, opening the bracket, it's equal to log log 10x. Alright, I haven't done that. I can actually collect like terms. Okay, I can say that this is log x to the squared is equal to log 10x minus log x. Okay, and the law of logarithm here states that log a minus log b is equal to what? Log a over b, right? So that is exactly the same thing I'm going to be using here. Then I'll have log x squared is equals to log into 10x over x. Alright, which means that x can cancel out x, so I'll still be left with this log x to the squared, okay, is equal to log 10, and log 10 actually is 1, so I have log x to the squared is equals to 1. Alright, so I can square root both sides, and that will be log x is equal to still 1, right? And log x is equals to 1. That implies that my x will be 10. Okay, let me show you the law of logarithm that applies to that quickly. The law of logarithm that applies to this is when we have a logarithm, something like this, logarithm a to b is equals to n. This is equals to a b n. So same thing applies to this. We know that this is base 10, right? In that case, that will be log x is equals to 10 raised to the power of 1. So x is equals to 10. That's the answer for the first one. So moving on to the next one quickly. So I hope it's very, very clear in how we have related this the rules of logarithm to solve this question. Okay, let's quickly see how to solve this one. This one is a simple one. Suppose we're given log 9 base x plus log x squared, then 3 is equal to 2.5. Okay, so suppose we have something like this and we want to solve it. What we need to do here is just to apply our normal rule. We know that rule of logarithm here, that a power of n b is equals to, when this n is coming to the other side, to be 1 over n log b a, right? So since we apply here, we have log x to the a plus 1 over 2 log 3x, okay, equals to 2.5. So I can still bring this power up. This can come up. I have log s to 9 plus log x also 3 to the power of 1 over 2. Well, just the same way it can drop. Then 2.5 in the real sense is 5 over 2. Okay, is 2.5. The law of logarithm again, which states that when we have a plus, it becomes times. If you have log a plus log b, that is log ab, right? Isn't it? So same thing here. I'll have log x to 9 times 3 1 over 2 is equals to 5 over 2. So in that case, if using the law of indices here, the law of indices in this place, you can actually work for it. We'll have something like this. 9 is the same thing as writing 3 raised to power 2. 3 raised to power 2 times 3 raised to power half, okay, is equals to 5 over 2. Alright, so in that case I will have log x to 3 raised to power 5 over 2 here also is equals to 5 over 2. Then we'll have, for this part, quickly let's just cancel out this point. We'll have just like the first example, this one goes here, okay, becomes the base. So I'll have 3 raised to power 5 over 2 is equals to s raised to power 5 over 2. Obviously we are having the same power, alright, the same power here, which means that these ones we have the same value. Therefore x is equals to 3. So let's move to the next question, so we can get the full context of what we are here to solve. So number 3, the next question. Suppose you're given, this one's actually very simple also. If I have 6, the logarithm of 2 base x minus 3, the logarithm of base x raised to power base 3, and I'm going to be having 3 log 5 and 0.2. Alright, so here to solve this we need to bring everything together as a single logarithm. So I'll have, this can be log x to the 2 raised to power 6, isn't it, minus log x to the 3 raised to power 3, right? I'll have 3 into log of 5. Alright, so 0.2 is 0.2 is 1 over 5. Okay, so I can write this as 1 over 5 raised to power 3. Then for the logarithm function, minus is division. Okay, so I'll have log x into 2 raised to power 6 is 64. That's 64 over 3 raised to power 3 is 27. So this has gotten its position that way. Then I will have this one also. I'll have log 5. Okay, log 5 into 5 raised to power minus 3 in that case, because of the 1 over. So that is minus 3. I can also bring down the minus 3, so I could just have log 5 and that will be 1. So log 64 over 27, don't forget base of x is equals to minus 3 log 5 and log 5 is 1. So I'll have log x into 64 over 27 is equal to minus 3, because log 5 here, this one here is 1. Okay, so now this can also become a base here. Y minus 3 becomes a power. So I'll have this 64 over 27 is equal to s raised to power minus 3. Alright, and to do that I can find the cube root of both sides. Okay, I can find the cube root of both sides, but I can also do this very interesting. I can say that this is the same thing as writing 1 over x raised to power 3 is equal to 64 over 27, and it's also the same thing as writing s raised to power 3 over 1 then 27 over 64, isn't it? I just take the inverse of both sides. So I'll take the cube root of both sides, so I can eradicate that cube. So a cube root of both sides, So I'll be having x is equal to 3 over 4. 3 over 4. And this will be my final answer for this question. So let's solve one more example quickly for a logarithmic function. Suppose we are given something like this, log x. Suppose we are given log x plus log x plus 1. Okay, x plus 1 is equals to log 12. So what you do is plus changes to time. So I have log x into x plus 1, right? And that is log 12. Alright. So in this case, I can strike out log, or I can actually find the exponent of both sides. So exponent of this one, and that will strike out the logarithm. Now, exponent is an anti-logarithm, that is opposite of logarithm. Just the way anti-log is the opposite of logarithm when you are doing your logarithm table. So this exponentiation is to strike out your logarithm, and also logarithm is opposite of exponent, so you can use it to cancel it out. So x times s is x squared, opening the bracket I made, so plus 1 plus x is equals to 12. So in that case I will have x squared plus x minus 12 equals to 0. That will be a quadratic equation, and if I properly solve this one, I should have x plus 4. If I properly solve that, x plus 4 and x minus 3 is equals to 0. Therefore my x plus 4 is equals to 0, and the x minus 3 is equals to 0. Then s is equals to minus 4 and x is equals to 3. So that will be the answer for that one. So I hope it's clear.